Hey everyone, welcome back. Houston Math Prep here. We're going to go over rational exponents. That's when you have a fraction in your exponent. Here I've got 8 to the 1/3. We're trying to figure out what 8 to the 1/3 is. Well, 8 to the 1/3, if you think about properties of exponents, and you had a 1/3 exponent, one way we might go about figuring out how this works is to think about, well, if I had 3 of those, a third and a third and a third as my powers, and I multiplied those together, then remember, properties of exponents tells me that I would add those together, right? So 3 copies of these multiplied all together would be 8 to the 3rd plus a 3rd plus a 3rd, and that is going to be 1. And I know that something to the first power is itself. So this tells me that when I have 8 to the 1/3 and I have 3 copies of those all multiplied together, I get a single copy of 8. So that's really, think about, this is 3 of the same thing multiplying together to get 8. And if we think about what number might work for that, in other words, can I multiply 3 copies of some number and get 8? Something times something times something, that something all being the same number, it turns out that that number is actually 2, right? 2 times 2 times 2 is 8. In other words, 2 cubed is 8. So we get that 8 to the 1/3 power is 2. Let's look at another example. Let's say I have 9 to the 1/2 power and I want to know what that is. Well, a similar idea, if I used 9 to the 1/2 and I multiplied it by another 9 to the 1/2, I could add those together, and a half plus a half is a whole number, right? It's a 1. So 9 to the 1 I know is supposed to be 9. So this is really saying that if I take 2 copies of 9 to the 1/2, this thing I'm trying to figure out, that gives me just a single 9. Well, can you think of some number that multiplies by itself, the exact same number, to give us 9? And we should notice, obviously, that it's 3 times 3, right? 3 times 3 gives us 9. So we get that 9 to the 1/2 is 3. So we get 8 to the 1/3 is 2, 9 to the 1/2 is 3. And maybe we start to figure out the pattern of this, and that's that the denominator of an exponent means that we take a root with that index. So our property for rational exponents here is if I have x to a power 1 over n, that's like taking the nth root of that. And so we don't have any funny business with trying to take square roots of negatives and things like that. We'll just say that x needs to be a positive number if you're taking some sort of an even type of root, like a square root or a fourth root, etc. So we get that 8 to the 1/3 power is the same as the cube root of 8, and 9 to the 1/2 is the same as the square root of 9. Remember, with square roots, we don't really write the index 2 in the root. Since it's the most common kind of root, we just leave the 2 off when we write square root. All right, we have several examples that we'll work through here with you. So we have first 16 to the 1/2. 16 to the 1/2, 1/2 would be the square root, so we want to think of this as the square root of 16, and that will give us 4. If we have 16 to the 1/4, that's the fourth root of 16. So that's saying 4 copies of some number gives us 16, and that's actually 2, because 2 times 2 times 2 times 2 gives us 16. Here, 81 to the 1/2, that's the same as saying square root of 81, and we should know the square root of 81. That's 9 from our multiplication tables. 81 to the 1/4, so we get the fourth root of 81, and that's saying what number multiplied 4 copies of that together will give us 81, and that's actually 3, because 3 times 3 is 9, times another 3 is 27, times another is 81. So over here, now I have some negative numbers, right? I have negative 27 to the 1/3. That's like saying the cube root of negative 27. Well, think about, in order to get a negative, 3 copies, I'm going to need a negative times a negative times a negative, right? So our answer's got to be negative, and then if we know what number 3 copies of it multiplied together gives us 27, that's 3. So if I take negative 3 cubed, in other words, I will get negative 27. Over here, notice that negative is not in the parentheses. We have negative 27 to the 1/3. So just be careful when you're doing these. These may end up the same, and they may not. So first, let's leave the negative out there. The 1/3 only applies to the 27, not to the negative. So we'll go ahead and think negative, and then what is the cube root of 27? And the cube root of 27, I think we figured out probably, is 3. So because 3 times 3 times 3 gives us 27. So we do still get negative 3 for this one, but we want to be really careful when our negative is inside what is being considered with the exponent or not. Down here we have 4 over 25 to the 1/2, so this is a fraction to a fraction power. So remember, this is just square root 1/2 power, and apply it to each piece, right? So remember, if I try to take the square root of a fraction, well, the square root of a fraction is just going to be the square root of the top separately, and the square root of the bottom separately, right? And we know these numbers. The square root of 4 is 2, and the square root of 25 is 5. So not too bad there. Don't let the extra fraction stuff scare you off there. Here we have 64 over 27 to the 1/3. So you can think of that as cube root of 64 over 27. You can do each of these cube roots separately. So think of this as cube root of 64 over cube root of 27. The cube root of 64, 4 times 4 times 4 is 64, so this one's 4, and we already said above the cube root of 27 is 3, so this one is 4/3 for our answer. Looking at some rational exponents when the numerator is not 1, when the top of the fraction in the exponent is not 1, so I have 8 to the 2/3. I want to begin by thinking of 2/3 as 1/3 times 2. That's the way we're going to think of this when we work through this. So let's go ahead and use properties of exponents and call this 8 to the 1/3 power, and then we're going to take that whole thing and square it. Remember, this is a property of exponents. When I have an exponent outside of another exponent with parentheses, then I actually multiply these together, right? So this is like saying 1/3 times 2 with our property of exponents, which is what we said 2/3 was. So now let's just think of 8 to the 1/3 like we were doing, and then we'll worry about this numerator, this 2, which becomes a square. We'll do that after. So first part, let's do 8 to the 1/3. So that's going to be like the cube root of 8, right? That'll be our first thing that we do, and then we'll take the square. So what is the cube root of 8? Well, that's 2, because 2 times 2 times 2 is 8. And then we still have the square left to do, the 2 from our exponent. So 2 squared now just gives us 4 for the answer there. Here I have 8 to the 4/3. So this one I'm going to think of as 1/3 times 4. So I want to sort of imagine this being 8 to the 1/3 power, and then all of that to the 4. Properties of exponents says now this would be 1/3 times 4. So again, now think of your 8 to the 1/3 as just cube root of 8. And then we'll have the 4th power. So we already did the cube root part. The cube root of 8 is 2. So that gives us 2 to the 4, right? And 2 to the 4 is going to give us 16. Okay, 16 to the 3/4, so a little bit different here. We want to think of this as the 1/4 power times a 3. Okay, so we will be taking 16 to the 1/4, and then we will cube it. This is still 3/4, but it's broken up using properties of exponents. So 16 to the 1/4, remember that will be like the 4th root of 16. And then we'll take the cube, right? Well, if 2 to the 4 up here was 16, then the 4th root of 16 is 2, right? So the 4th root of 16 is 2, and then we need 2 cubed, and 2 cubed, 2 times 2 times 2 will give us 8 for our answer. Here we have 25 to the 3/2. Let's try doing this all in one shot here. So the bottom is going to be the type of root that we have. So that will be the square root of 25, and then what we'll need to do at the top is going to be the power, right, that we apply. So this tells us square root and then cube. So we get the square root of 25 and then cubed. That's going to be 5 cubed, and then 5 cubed, 5 times 5 times 5 will give us an answer of 125. So some extra examples here. We have some negative powers and we have some fractions. We have 4 over 9 all to the negative 1/2. So remember, negative in the power means reciprocal. So let's go ahead and do the reciprocal part. We're just doing the negative part of the exponent. That becomes 9 over 4, and that will be now all to the positive 1/2. We've already done the negative part of the exponent, which is reciprocal. So now to the 1/2, remember that just means the square root. And if I have a fraction to a power, I apply this to each part of the fraction. So that's going to be square root of 9 on top and square root of 4 on bottom. Square root of 9 we know is 3, and square root of 4 we should know is 2, so we get 3 halves. For the next one, 8 to the negative 2/3. Let's do a similar thing here where we take care of the negative in the exponent first. Negative means reciprocal, so I'm going to think of this as 1 over 8 to the positive 2/3. Okay, so we've done the negative part of the exponent. Now let's think of this as a root and a power. So the first thing we'll need to think of is to the 1/3 power, that's a cube root. So we'll need to take the cube root of 1/8 first, and then the 2 says we're going to go ahead and square that. So if I figure out on the top, what's the cube root of 1? Well, that's just going to be 1, right? 1 times 1 times 1 is 1. And what's the cube root of 8 on the bottom? And that would be 2, right? 2 times 2 times 2 is 8. So that's the cube root part. Now we still have the square left. And now I just square each piece, right? 1 squared, 1 times 1 is 1. And 2 squared, 2 times 2 will give us 4. So we get an answer of 1/4 for this one. Looking at number 15 here, 81 over 16 to the 3/4 power. So thinking of the bottom of the exponent first, and then this top part, we have a 4th root, and then we have a cube. So what we'll do is go ahead and apply our 4th root first. So we have the 4th root of 81 over 16. And then we'll have a cube on that. So let's do our 4th roots first. So the 4th root of 81, 4 copies of something gives us 81, and that something is 3. And then the 4th root of 16, 4 copies of something gives us 16, that's 2. And now I still have my cube on the outside, right? So I just cube each piece, 3 cubed, that will give us 27. And 2 cubed on the bottom will give us 8. All right, looking at our last one here, we have 1 over 27 all to the negative 4/3. So first let's take care of our negative in the power. Negative means reciprocal. Now if I take the reciprocal, that gives me 27 on the top and 1 on the bottom. 27 over 1, I'm just going to write that as 27, so we don't have a fraction anymore. I think that's kind of nice. Okay, so 27. So we've already used the negative from the exponent, now the 4/3 power. So do the bottom first, remember that's the type of root we have, right? So we have a cube root, that will be the cube root of 27. And then we'll have to do the 4th power. Remember this is type of root, type of power. So the cube root of 27 gives us 3. And then we'll still have the 4th power, and so 3 to the 4th will give us finally 81 as an answer. All right, everybody, hopefully this helps you with your rational exponents, figuring out how to read these, some with reciprocals, some with fractions. Thanks for watching. We'll see you in the next video.